Hello. The following report is our group's bid proposal for the Blizzard Valley Bank project for the class CIV420. The following video will provide a detailed summary of our assumptions and explain our overall construction approach for developing our bid proposal. It's important to note that this is a fictional project prepared by the students at the University of Toronto. The following report was prepared by Christopher Bekmezian, David Hegarty, and Andrew Pavia. So the overall purpose of the video is to describe the assumptions and overall construction approach. Throughout the video, I'm going to be flipping back and forth between our actual report and our construction schedule and our overall plan for the site. Basically, what I will be doing in the video is that I will be trying to describe our assumptions in greater depth that could not be achieved in the report. And basically, throughout these assumptions, I will describe how our group approached the cost analysis and overall constructability of the project. So just beginning with the executive summary, this just provides a detailed summary of the overall cost and duration of the project. So as evident, the total cost of our bid proposal is $1,984,065.26, and the project will be completed within 79 working days. So I'm not going to go through the executive summary in detail as it's pretty straightforward. It just, again, describes the overall assumptions and our overall construction approach for the project. So moving past the executive summary, we get into the introduction and overall assumptions that our group made about the project. So as there was no designated location for the project other than that it was in Northern Ontario, what our group assumed is that the project is located in Blizzard Valley, Ontario, which is located in Northern Ontario. And based off of research that we conducted, we determined the overall soil characteristics of the region. The soil characteristics that we determined were pretty common throughout Blizzard Valley was sand. So since sand was the most dominant form of soil throughout the region, we assumed this to be common throughout our site. And for this reason, it was used for all earthwork calculations. So in this section here, I'm going to describe our overall methodological approach for developing our bid proposal. So as with any construction project, you obviously want to try and minimize your overall cost and time spent on a project, but you don't want to compromise constructability. So in section 3.3 here, I basically describe our overall approach for the construction on the site. So the first step that we would be uh, conducting when we arrive to the site would be to grade the surface. So in the site plan here, this is the overall site, and as can be seen, there's the building pad for the building itself. So the first thing that we would be doing when we would arrive on site is to roughly grade the surface. So grading the surface would basically just prepare the surface so that the excavator could come in and remove the contaminated soil. So contaminated soil is one of the biggest issues that our group had experienced on the project. So determining the contaminated volume was a big issue that we had experienced because we were trying to decide whether if it was important to remove all contaminated soil from the site or to just remove the contaminated soil that will actually just be excavated from the building structure itself. So what our group determined was that we will only excavate contaminated soil within the building foundation. And the reason that we decided to choose this was because if we were to excavate all soil throughout the site, it would significantly increase the cost of the bid. And as we believe that the soil is only, as we're only disturbing the soil within the foundation, the other contaminated soil was assumed to just remain in its existing position. So for this reason, we did not decide to excavate it. So in this section here, in section 3.3 here, I basically just described the overall approach as was described before. So when you arrive on site, the grading begins, and then the next step is for excavators to remove the contaminated soil. So through calling various contractors, we determined that GFL Contracting is actually in the business of removing contaminated soil. So what we will be doing is we will have excavators be loading soil into GFL trucks. So excavators will be loading contaminated soil as highlighted in this region here and in this region over here. So basically excavators are going to be loading this contaminated soil, and you're going to have trucks driving throughout proposed gate C and proposed gate B. Just to note, we added these gates to the project as gate A was the only existing gate on site. We added these gates in order to improve overall constructability. And since the site is located within Blizzard Valley in a rural area, we don't really tend to think that there's going to be any major traffic problems having various gates on site, and we assume that trucks will have various access. Trucks will have no problem accessing the proposed roadways and these gates as on site. So after the contaminated soil is removed by GFL contracting, we will have the excavators only excavating the trenched areas of the site. So since the site doesn't have, or since the building, I should say, doesn't have a basement, we will only be excavating trenches for placing the foundation. So as can be seen in this diagram here by the dotted lines represent the trenched areas that the excavators will follow. So as described in section 3.3 there, we indicate that excavators will begin on the east side of the site. So upon removing the contaminated soil, they will back up and move along here, and then they will continue to excavate the trenches for the foundation that's going to be placed. So in order to limit cost, what we determined was that the excavators will excavate the soil from the trench, and then they will stockpile it right next to the trench where loaders will pick up the soil and they will stockpile it on site. So now, since the contaminated soil has already been removed from the site, we can still use the soil that was picked up from the trenches. So now the reason that we've decided to do this was because we don't want to haul more soil off the site than we have to if it's still reusable. So this was one of the big areas where we were able to achieve major cost savings. So that was one of the major things that we had accomplished on this. So then upon the stockpile being generated over here as indicated in the diagram, then we can have the form working crew come in and begin to place foundations. So foundations will be placed throughout the trenches, obviously, and we assume that the trenches will be 2.6 meters wide at the bottom. So having them 2.6 meters wide at the bottom was calculated based off of the average footing width to be 600 millimeters and the average foundation wall to be approximately 200 millimeters. So we added another meter on each side of the foundation in order to allow for the formworking to be placed and to allow for the formworkers to have room. And then to ensure safety and stability, we sloped the sides of the trench at a 1-to-1 ratio. Sloping the sides at a 1-to-1 ratio was determined based off of assuming that the sand is a type 3 soil, and this will allow for safe excavation of workers working throughout the trenches. And then upon the completion of the foundation, the soil will be moved from the loaders back into the piles where it will be backfilled. And then upon being backfilled, we will have a compactor coming in to ensure that the soil is properly packed to 98% compaction. And then upon the soil being packed, we will have bulldozers finally grade the surface. And then once this is complete, the remaining construction and concrete work can proceed. So that's just an overall summary of our construction approach and methodology as is seen in section 3.3. So in terms of market assumptions, it's obvious that the construction industry is a very highly competitive industry. So what we want to try and do is maximize our bid in any way possible and try and see where cost savings can be achieved in order to ensure that we can be awarded the project. Since ABC Contracting is a small company, we will be willing to purchase equipment if necessary. And we assume that we will have projects lined up within the next 5 years. So in terms of general contractor assumptions, Condrain, they are a large company working throughout Canada and the United States, and since we're assuming that they will have future projects, we want to obviously try and do well on this one in order to ensure that we can work with them in the future. And that just the last thing to note is that the owner, we're assuming that the owner isn't really well informed about construction, so we want to make sure that we want to minimize as many errors as possible, and we want to ensure that we're using proven tactics to verify that our construction methodology and approach will be sufficient and work properly. So then in section 4.0, we talk about the overall earthwork assumptions that we made. Now, the overall earthwork assumptions and the volumes that we had calculated were based off of the Revit file provided. So through the use of the Revit file, we calculated the earthwork volumes, and these summaries can be seen in these tables here. So in terms of total cut, we found that there should be approximately 15,255 and 91 bank cubic meters of cut volume, while there will be 16,402.03 compacted cubic meters. It's just important to note, as when I was describing in the previous section, when the loaders are backfilling the material, there's also going to need to be additional imported soil, as can be seen per this line here. So the reason that we need to import soil is because since the contaminated soil was removed, we need to just bring in the remaining soil to ensure that the trenches can be backfilled and the areas that were contaminated can be backfilled and to achieve the proper compaction that they need. So that's the additional soil that's being brought in. And we estimated that cost to be approximately $121,000. And the reason that cost is so low is because we were able to reuse a lot of the soil, which makes our bid more competitive. Had we removed all that soil, had we removed all contaminated soil and removed all trench material as well and brought in entirely new soil, we were looking at an approximate 80% increase in our overall cost for earthworks. So for this reason, we chose to proceed with that option. Then in terms of overall trenching and grading, as was described in the overall construction approach, this basically just talks about how we set the foundation width and the overall bottom of the trench and top of the trench and slope the sides of the excavation in order to ensure safe excavation for our workers. So the following figures basically just describe how that slope works. So as can be seen in this diagram here, the slides are sloped at a 1-to-1 ratio. This bottom width here is 2.6 meters. It's 1 meter on each side, and then the foundation width there is 0.6 meters. So that's just a visual representation, just so you can see that. And then in this figure here, this just determines the overall cutting and grading of the surface. Now it's important to note that since the site, since in the project file, there was not an existing site grade. Like for example, we didn't demolish a building in order to put this up. So what our group assumed was that the grade that was existing there, we were just going to match that as our final grade. So for this reason, there wasn't very much cut and fill from the surface because we were assuming that the original grade was just going to follow the final grade. And basically what can be seen in this volume is just like the cut and fill volumes that were calculated based off of Revit, just to create like an overall flat plane that was level with the existing plane. So since it's following, there's again very minimal cut and fill volumes for this plane itself, and that can also be seen in this chart here, as there was only like 143 bank cubic meters for cutting and 1445 for filling for final grading. So that's why those numbers are so low. Had we assumed that the final surface was completely flat, or a completely different grade, we would have produced much larger numbers in those areas. So in terms of our overall earthwork cost and the way we came up with the equipment and overall construction approach, we used cost analysis to determine this. So the way that we basically conducted this cost analysis was we determined the productivities of various construction equipment, and we wanted to see which combinations would result in the fastest time while still minimizing overall construction costs. So basically these are the various productivities we found for scrapers, graders, dozers, excavators, loaders, and vibrators. So now it's important to note that this site is relatively small in nature, so we decided not to use the scrapers and the graders, although we conducted the scraper and grader cost, the productivities, and also conducted their cost analysis as seen in the appendices. We realized that it just doesn't make sense to be using scrapers and graders because the site is just so small. So we believe that a dozer would provide a more logistical approach for grading and cutting of the surface. And then obviously you're going to have an excavator just excavating the trenches, so a scraper or a grader wouldn't be sufficient there. And then in terms of a loader, which would be responsible for moving the excavated soil around the site, and a vibrator for compacting it. And it's also important to note that we didn't consider the truck equipment cost or truck equipment productivity in earthworks. The reason that we didn't consider truck productivity in earthworks is because trucks were only going to be required for removing the contaminated soil. And then we also assume that trucks will be able to bring the imported soil to the site whenever available. So we determined that time that they're delivering the soil to the site, it wasn't going to be on like a critical path where they were going to delay us. So that's why we didn't consider any trucking analysis there. And that's basically how we came up with the productivities of those. So moving on, we determined that the overall best effective combination of equipment to use was to use to use to use 2 excavators and 4 loaders for excavating the trench soil, and to also use 4 loaders for putting the soil back. And then we also decided to use 4 vibrators and 1 dozer for compacting the soil. So now detailed cost analysis of these can be seen in the appendices, which I'm not going to go through for the purpose of this video as they're pretty self-explanatory in the appendices. But just in terms of overall contracting cost, we determined that the earthwork can be completed for $527,138. In comparison, had we had subcontracted this work, it would have costed $2,862,000 just for earthworks. So as can be seen right here, it's clear that we're offering significant cost and time savings. Well, actually, in terms of time savings, we assume that the equipment productivity was the same in both cases, except it's just we can do it for much cheaper as we're not paying a subcontractor who's going to be marking it up, which is responsible for such an increased cost. So just moving on to contamination. Now, I talked about it in the previous section, but in terms of contamination, there was various methods considered for treating the contaminated soil. In terms of the overall contamination methods, there's 3 major methods for dealing with contaminated soil on site. So the first method is excavation and disposal, which is the method that we're using. Then there is vitrification, and then basically what vitrification is when metal impurities are physically locked within the soil. And then the last soil the vitrification method is when heat is used to solidify the metal impurities, while in solidification, metal impurities are physically encapsulated within the locked soil. But the reason that we didn't proceed with vitrification or solidification stabilization is because these methods are just too expensive. And since these methods are so expensive, it just doesn't result in a logistical analysis or selection. It's also important to note that these methods are new, which are responsible for increased cost. It's important to note that this table here is just a comprehensive summary of the equipment that we had used and basically our selection of equipment when we were calculating the productivities and our cost analysis. So just moving along, this section here basically provides a cost comparison of the various decontamination methods for the soil. So again, we decided that it's best to proceed with the excavation and disposal of the soil, which costs $300,000, as indicated by speaking with GFL, who will be responsible for removing all our contaminated soil. It's significantly cheaper than the solidification and vitrification costs. So now the final section of the report is our concrete cost. So basically, for determining concrete costs, there was 3 options that were available. It was either purchasing fresh concrete from an external supplier A, purchasing fresh concrete from an external supplier B, or installing a batch plant on site. And basically, in each case, the trucks can be subcontracted or purchased. So through our cost analysis forecasting, we basically compared the various methods, and these various methods can be seen in these appendices, or sorry, these tables here, which basically shows the cost if you were to purchase with 1 or 2 trucks, and if you were buying from either supplier A or supplier B. So in terms of the overall cost per meter cube, this is what supplier A is charging, while this is what supplier B was charging. Now, in order to simplify the calculations, what we assumed was that a concrete truck and a dump truck have the same volume and that they travel at the same speed. So this basically just allowed for more comprehensive or more simplified times for calculating like cycle times in order to calculate overall truck productivities. Again, detailed calculations can be found in the appendices. And then we also compared the alternative of using a batch plant on site. And basically in the batch plant on site option, what we would be doing is that we assume that supplier A would be supplying dump trucks with material, who would be hauling the material to the site. And while hauling the material to the site, the batch plant on site would then come up with combinations of various aggregate and sand and cement, and basically combine and produce a concrete produce a concrete mix. But just in terms of logistics and overall reduction in savings that we could achieve with a batch plant, we determined that it was not the best option, and that it would just be more economical to have supplier A deliver the concrete to the site. So then, just in terms of our total cost for the project, the overall cost, as indicated in the executive summary, was $1,984,000. $1,984,065.26. So this basically was a overall summary of our project. In terms of profits, we had marked that up at 15%. However, depending on if through discussions with the contractor, through discussions with Condrain, if we determine that our number is within the running and we are in a competitive position, we may even reduce our profit margin in order to increase the possibility of being awarded the job and gaining future projects with Condrain. So if you have any questions regarding the project, please feel free to contact the owners of this report, who are Christopher Bekmezian, David Hegarty, and Andrew Pavia. Hopefully this video has provided a detailed, comprehensive summary of the assumptions that we have made throughout our CIV420 project. Thank you. Bye-bye.